EU's framework programs are the main EU funding mechanism for research, development, and innovation. The current framework program is called Horizon 2020. Universities, research organizations, and individual researchers from EU member states are eligible for framework program funding. Currently, British scientists have access to a wide variety of EU research funds. During FP7, the UK received €8.8 billion funds from EU. Recently, the Horizon 2020 program has awarded €4.6 billion to the UK so far. The UK is one of the largest recipients of research funding in the EU. Therefore, many UK scientists were focused on the effects of Brexit to acquiring funding for their research. For those considering to apply to the Horizon 2020 funding scheme, its availability to them suddenly became a cause of concern. Will EU continue funding UK research after Brexit? In this video, we will use normal form game to solve this problem. In the normal form game, each player simultaneously chooses a strategy, and the combination of strategies chosen by the players determines a payoff for each player. There are three elements in a normal form game. Firstly, the players in the game, which is UK and EU. Secondly, we need to know the strategies available to each player. Here, UK and EU both can choose between found and not found. The last one is a payoff received by each player for each combination of strategies that could be chosen by the players. The payoff structure of this game has four situations. If only EU funds and the UK government doesn't pay for UK research, then EU gets -4 and UK gets 0, because EU loses some money. It is the same situation if only UK funds and EU doesn't fund, then UK get -4 and EU get 0. If both EU and UK fund, then they both lose some money and get -2. If neither of them contribute to the scientific research, then UK scientists will not have funds to continue their research. We all know that developments in science and technology are essential for the overall progress of mankind. Therefore, in this situation, we assume UK get -10 and EU get -8. We then fill in this matrix with these numbers. We can easily find that this game has no dominated strategy for either player. Therefore, we need to find a Nash equilibrium in this game. The trick to find a Nash equilibrium is, for each player, single out his best response for each strategy played by the other player. And if the best responses of the two players can be met in one strategy profile, this is an equilibrium. Since UK found is the best response to EU's not found, and EU choose not found is a payoff maximizing strategy to UK's found. In other words, when EU plays not found, UK would not want to switch his strategy to not found. Therefore, UK will stick to his strategy found. And the same holds for EU. So when UK choose found and EU choose not found is a Nash equilibrium. We can also find the second Nash equilibrium is strategy profile not found, found. The former equilibrium has a higher payoff for EU, while the second equilibrium is a more desirable solution for the UK. Now we successfully find two Nash equilibria in this game. However, if UK and EU move sequentially, then we will get only one pure strategy Nash equilibrium, which depends on who moves first. But we can find only one unique mixed strategy Nash equilibrium in this game. Just suppose that UK plays found with probability P and EU plays found with probability Q, so that EU is indifferent between playing found and not found. We let EU's payoff from found equals EU's payoff from not found, and by calculation, we find that P equals 2/3. Therefore, if UK plays found with probability 2/3, EU is indifferent between playing found and not found. We need to repeat the same exercise to see how UK can be indifferent. By plotting the best response function for both UK and EU, it also shows the two pure strategy Nash equilibria and the unique mixed strategy Nash equilibrium. We can get the conclusion. There will be three results: only UK found, only EU found, EU and UK found with probabilities. In reality, the situation is very complex. UK and EU may collude on this issue. They may also act sequentially. Moreover, the cost of Brexit for science is not simply monetary. When the UK leaves Europe, Britain's scientists will likely experience not only costs to their funding, but also barriers to their mobility. After Brexit, it is vital that the UK should still be seen as open to scientific talents. The government needs to do something to send the message to the scientific community and let UK remain to be one of the world leaders in technology and science after Brexit and beyond.